Question 47, we've got a couple fire stations, which sounds like some questions from last semester. We've got the distance between the fire stations, and they have a couple angles worked out for us already. So this bearing is 65 degrees to that one and 80 to this one, which means this must be 15. So, oops. 15, try to make it look like that. And then there's another bearing over here where they give us that this is 70, and from this we were supposed to be able to figure out the distance from this station to the fire and this station to the fire. So basically find two sides of your triangles. Now, kind of the problem with this one is, and one thing I really like about law of sines and law of cosines, is if you're not sure if you have enough information, you can just start it and try. So if I'm trying to solve for x with law of sines, I've got to pair it up with the sine of its opposite angle. And although they didn't tell me this angle was 15, you know, if this whole thing is 80 and this is 65, it's pretty quick to figure out that that's 15. And then I know that I have to set it equal to a length that I know divided by the sine of its opposite angle. Now, I don't know this length, that's another part of the problem, but I do know this length, so I'm going to put 30 over the sine of his opposite angle, which would be over here. And that creates a little bit of a problem. I don't know this, and I don't know this, so I can't solve this equation yet. I've got to figure out what this angle is, and then law of sines will work out nice and neat. But looking in this mess, this 15 degrees is pretty much the only easy angle to find, and I need more angle information. So one of the things, little tricks we had to do last semester, and this comes up quite a bit with bearings, but if this was a north line and this is a north line, that guarantees that they are parallel. And the nice thing about parallel lines is if you have a line intersect them, which we call a transversal, then you have all those angle relationships. So I look at this one and see it's in the top left, so it's going to alternate with the bottom right, and they're in the interior of the two parallel lines. So if this is 65, that is 65. And then if I know this whole angle is 135, and I know this is 15, I could subtract these two from 180, and then you get that this angle that the fire makes with the two stations is 30 degrees. So again, kind of the nice thing about these formulas is you just start using them, and then if you don't have enough information, it's pretty obvious what you need to go and find. Doesn't mean that's easy to find, but at least you know what you need to be doing. So then it looks like this distance, what I labeled as x, is going to be 30 sine of 15 over the sine of 30, and that is ready to be thrown in the calculator. About 15.529 kilometers. Okay, and then the majority of the legwork is done, but it also wanted to know this length, so I called it y. So y needs to be put over the sine of his opposite angle, but I've already had to figure that out for the first part, so that's ready to go. And then you need to set it equal to a different length divided by the sine of his opposite angle. So I'll just reuse the 30 and the sine of 30. And so it looks like y is going to be 30 sine of 135 over the sine of 30. And as long as we are careful about how we put that in so that our calculator does the order of operations correctly, we shouldn't have to guess if that makes sense or not. But of course, my recommendation is to also put these links on your picture. And of course, Make sure that the biggest length of that triangle is opposite the biggest angle and smallest length is opposite the smallest angle. If those two things are not true, then you know you have a mistake somewhere.